Parent-child well spacing optimization in the Fayetteville Shale. As a continuation from the summary of our last video, we collected all necessary production data, filter data, obtained offset spacing, and analyzed data to notice trends.
We decided to only look at the children on either side of the parent well to try to get a better understanding of the well spacing effects, in order to make sure that the wells we are comparing had similar production characteristics. We filtered out data with a cluster spacing less than 65 and greater than 95 feet. We only used wells that were completed using a slick water completion fluid and the wells that had to be in the completed zone. If you look at the graphic here on the right, we will only take the shortest distance if a child has multiple parents. This is done because as the pressure is drawn down in the reservoir, the parent well that is closer to the child is going to have a greater effect on the child well's overall production, so we only took this parent-child relationship to be statistically relevant.
Okay, after gathering all of our data, these are the graphs that we were able to produce. This is the pilot area A, and it's the 90-day cumulative production graph versus the offset spacing. And on the y-axis, you're looking at the percent difference in the parent versus child 90-day cumulative production per foot of CLAT. And on the x-axis is the perpendicular distance between the wells, or the offset spacing. A positive number on the y-axis indicates that the parent well outperformed the child well by that percentage, and a negative number indicates that the child well actually outperformed the parent by that percentage. We also have three buckets for the data. The blue is going to be low cum, the orange is going to be a medium cum, and the green is going to be high cum. And that is how much the parent well had produced at the point of the child's first production date. And a 0.2 million cubic feet of gas produced per foot of CLAT is, if you were assuming about a 5,000 foot lateral, which is common in this formation, that's about a BCF of gas. And a 0.35 is about 1.75 BCF of gas produced. As we can see from the data, we are starting to see the child perform equally to the parent at different offset distances based on how much the parent well had produced. We're seeing a nice linear drawdown until the trend lines are crossing the x-axis, and this is indicating that that is the point where the child is starting to perform equally to the parent. And this could be because we're finally reaching a virgin reservoir rock. This just means that we're going to have to space our wells off even further the more that the parent well had produced. So we're going to break this down a little bit and look at the low cum example. It's sort of interesting because in the low cum example, we're having kind of after this 600 foot mark, we're having the child perform better than the parent. And this is only seen in this low cum case. More than likely, since the low cum parents are closer to their children in terms of their first production dates, the children are stealing more of the parents' gas in the first 90 days of production because the parents' fractures are relatively new and the reservoir pressure is still high, so the gas can migrate more easily to the newly completed child well. This gives a higher 90-day cumulative production for the children. This is still good to show the point where the child's production begins to increase, but in terms of long-term production, I would not expect the child to drastically outperform the parents in this low cum situation, as much as what it's showing is up to 60% better production. And this actually held up, which I'll show you in the next slide. If you look at the percent difference in the parent versus child production after 1 year, the data starts to level off at about 0 after the 600 foot. Here's the medium cum, and as we can see, the line is a little bit less steep, and it looks like it's going to cross the x-axis a little bit further, maybe around anywhere from 800 to 1,100 feet. So you're going to have to space off those a little bit further. And then for these high cum wells, you're really impacting your child's production negatively anywhere from 40 to 60%, kind of regardless of where you're putting those wells. So you may have to space those off even further to get an accurate child's production. Okay, and this is what I was talking about. This is the 365-day case. And as we can see here from the low cume example, even though the data is a little bit more shotgunned, it doesn't look quite as pretty, but you're not getting these 60%, the child outperforming the parent by up to 60%. It's kind of starting to level off at 0, which is backing up the point that I made in the previous slide. The medium cume example is showing about the same trend. It's crossing the x-axis, probably around the same point, anywhere from 800 to maybe 1100. So that's just showing that we need to space off a little bit further for this case. And then once again, for the high cume, that child's production is negatively impacted, kind of regardless of where we are. Okay, this is the last area that we decided to look at for this part of the project. This is the pilot areas O and N, and it's the exact same graph that you were looking at earlier, just for a different pilot area. And we just want to show that there are similar trends. For the low cume, it's crossing about the same place, kind of that 600-foot mark for the offset spacing. For this one, it was difficult for me to put a trend line through because it's obviously not showing that well of a trend, but the reason I put the trend line in there is it's more of a best estimate for as we drill and complete and start producing more wells. I would expect it to kind of follow this downward trend, kind of going towards that 800 to 1,000 foot optimum offset spacing. And then once again for the high cume, it's also looking like it doesn't really matter where you put that child well, you're going to negatively impact your child's production. And so you're probably going to have to put it well over 1,000 feet away in order to get back to the optimum parent production.
In the future, we will need to conduct an economic study to determine if profitability can be maximized. We will also want to expand the study to more pilot areas. We should continue updating the project management plan as the project progresses and finish making the final presentation as well.